Hello friends, we are going to start STAAD Pro Structure Analysis and Design program. So double click to icon STAAD Pro. In this class we will start multi and we will start analyze this multi with earthquake. So start project, new project and click to space is 3D and mention the name, file name, say multi structure. Save the location where you want to save your file because STAAD makes its multi files. So save this file into a folder and finally go to next. Then this is a one flexible command. Where do you want to go? So in this command click add beam and finish. You can make multi with a coordinate method or copy paste or snap node, any means. But if you want to make a ready-made structure, it is also possible in STAAD Pro. So close this snap node beam command and in menu bar go to geometry and select run structure wizard. In this run structure wizard, select model type frame model. There is various type of structure in truss. You will get truss model structure and space solid. There are the various regular structures, but we will go with frame model. In frame model select bay frame. This is your bay frame and this is a ready-made bay frame, and if you want to change or configure this bay frame according to yourself, you can change it. For example, I double click to bay frame and suppose if I mention length 15 meter and number of bays along the length, means in this length there will be a 4 partition, and suppose I change it to 5 and height is 15 meter, and suppose I change it and make it 30 meter, and in this 30 meter I select number of partition 10, means 3030 divided by 10 is equal to 3 meter. So my partition will be 3 meter. Floor height, you can say floor height, and width, so say 15 meter, and in this width we decide number of partition 5. So 15 divided by 5 is equal to 3. 3 is your partition spacing. So number of bays means spacing. Then click to apply. Then this is your geometry. This is your below plinth level, and this is your plinth level, and this is your ground floor G, and this is 1 2 3 4 5 6 7 8. So we can call it G plus 8, or you can also call it 9 story. So this is wizard structure, but if you want to import this structure into STAAD Pro, so go to menu bar, select file and click to merge model with STAAD Pro model. With this command, this model will merge to STAAD Pro. So here wizard asks, would you like to transfer oblique merge this program, this prototype into STAAD Pro? Yes. Again it is asking, here it is asking because if you want to change the height of the model, if you want to place it in a space 10 meter above, so you can mention 10, so it will be above 10 meter. Or if you want to create one more wizard structure, so you can create and place it over previous structure. So in our case we are not going to change anything and click to OK. So this will be our structure, and now I want to see the dimension. that I want to, you can say, cross check the dimension. So you can easily cross check it with the help of command display node to node distance. In this display node to node distance command, this will, we will also get this command into tool, and in this tool it is um here display node to node distance, and display node to node distance you can check the dimension. This is d7 and your foundation is 3 meter. Your depth of foundation is 3 meter. Suppose if you want to change the depth of foundation, you can change it. So for changing the depth of foundation, first of all you need to reduce the structure height 1 meter. So what will be the procedure? The procedure is, go to the page control, this left hand side is your page control, and click to note cursor. Note cursor is used to select only notes. Select note cursor and go to front view. This is your uh, this is auto save command, and in every 5 minutes STAAD Pro save its file. Click to yes. Click this box, this cube. This cube is your front view. You can easily view this cube displayed according to its shaded part. And in this front view, I select with the help of drag command. Here, I select all the nodes except bottom nodes, base nodes. So, what I am going to do, I am going to reduce the height of the above structure. So you can call it, I am going to move this structure. So for moving this structure here, structure word is, in STAAD Pro structure word is uh, used with geometry. So go to menu bar, select geometry, and click to move command and select joint. Here in this joint command, go to y direction and mention -1. -1 means it will reduce the selected portion will go down. How much? 1 meter. Then press OK. Here, if any of this node of the entire being moved fall on existing model. Okay, we want to proceed this. Yes, this will be our structure. Our now our foundation is 2 meter. If you want to again check the dimension, click to display node to node distance and see 15 meter is your length and width, and height is 27 meter, and this is your foundation. Now if you want to remove this dimension, so see here in this command display node to node distance, there is one more command, remove all node to node distance. So click to this command, and this command is also displayed in menu bar, tools, remove node dimension. Okay, our structure is ready. Now we can say our geometry part is complete. This is our page control, and we will proceed according to this. Now proceed to general. uh, our geometry tab is completed. We are moving towards general. Here in general sub tab is property. So property means your section, your size of your section, material, that will be defined here. I say that will be defined. So use command define, and you can change the shape of the section according to yourself. So I am going to use one square shape. Say to make square shape, mention both dimensions same, 0.35 meter by 0.35 meter. This will be my square, and here it is rectangle. I am providing both the dimensions same. Add this command, and material is by default concrete. And my next, I am going to make rectangle section. So YD, here this YD shows depth of the section. So mention YD, and width will be 0.23 means 230. mm, and depth is 450. Then material is concrete, add, close. Now if you want to assign this section on your member, you have to select your member first, then assign. Say I select this property, or you can call this section. This section is uh, square section, and I want to assign this square section on columns. So to assign this section to columns, select your column first. So to select one column, it is very typical. So in STAAD Pro, there is a good command in menu bar. In menu bar, select. In select, there is a command beam parallel to X, Y, Z. Column is parallel to Y axis, so we click Y axis. All column is selected. Then section is already selected, column is selected, and go to assigning method. In assigning method, select assign to selected beam. Assign to selected beam, and yes, see, all the members are assigned. This R1 reflects here. R1 means reference 1, and reference 1 means section this, material this, means this member is assigned with this section. Now similarly, go to another section and click to that section first, then go to menu bar, select beam parallel to X. Our beam is parallel in both direction, X and Z direction. Beam is parallel to X and Z. Then assign to selected beams, assign. So our property part is completed. Now we move to specification. This command will be further explained in further classes. So we skip this command and we move to support. Support means your pin support, fix support, roller support, whatever. So for this structure, suppose if you want to make a fixed support, so if you want to make a fixed support means you want to create, so go to create option in right hand side, click to create, and your by default your support is already selected, fixed support. Click to add. See, your support 2 is all generated, or you can say it is created. By default support 1 is your no support. If you want to remove any support from existing support, select this command, and if you want to create, then click support 2. So I want to assign this fixed support here in base. So to assign fixed support over base, I am going to front view here in left portion, front view, and in this front view select base nodes. Your base nodes are selected, then click to assign to selected nodes, assign. See, all the nodes are selected. Then go to loading. Our support part is clear. Then go to load and definition. So in this session we are using earthquake analysis. So we will move to definition part. In definition part, select seismic definition. Seismic definition, here from here we will assign seismic calculation. So in seismic definition, click to add, and here in STAAD Pro, when you click add, there is one dialog box open. Its name is seismic definition. In this seismic definition, it is asking your code. As per Indian code, your earthquake code is IS 1893 part 1 2002. I select IS 1893. So you can mention this value according to your code, or there is a good option, generate command. So click to generate command, and you can select your city, in which city you want to uh, assign earthquake. So suppose if I select Bhopal. So Bhopal comes in zone 2. This is intensity. So if you don't know your city name, or if your name is not available here, so you can go with zone wise. Click to zone, or you can select your zone. Seismic zones are zone 2, zone 3, zone 4, zone 5. Suppose I select zone 2. Now select response reduction factor. This is available in table number 7 in earthquake 1893 part 1 2002 code. This is if you want to analyze a structure with special RC moment resisting frame, means it's a RC frame. You are analyzing it with special cases. Here this is defined ductility of your structure, and one more option is there, ordinary RC moment resisting frame. This is ordinary moment frame, and its value is 3, and is for a special RC moment resisting frame its value is 5. If you don't know the value, you can just click and state itself reflects its value. Suppose we are taking special RC moment resisting frame. Then next is importance factor. Importance factor is also you can see in code. It's table number 6, and importance factor, important building, if it is value is 1.5, means it comes under the special cases like hospital, multi structure, commercial, and mm, assembly halls, etc. So I select important building, and rock and soil type. Here in rock and soil type, you can select soil according to your site condition, say medium soil. Structure type, you can select according to your structure. So in our case we are selecting RC frame building, and then this parts are optional. You can also mention after creating the, after clicking to generate. So we have mentioned the zone 0.1 means it's a zone 2. We have mentioned its intensity, response reduction factor 5, or importance factor 1.5, rock and soil factor 2 means it's a medium soil, type of structure 1 means is RC structure, damping ratio according to code we are using 0.05, means it's a 5%. We cannot take value more than 5%, so I convert this 5% into decimals, 0.05. And you can, now you have to calculate this period in x direction, period in z direction. This will be available in code page number 24, left hand side and right hand side. Its formula is T is equal to 0.09 into h divided by under root d. Here h is the height of the structure and d is your dimension, that we have taken 15 meter. 15 meter, according to the our structure height is 27, and this is the height of our structure, height is 27, and its dimension is 15 meter. 15 meter, this is dimension, and according to this we have to calculate. So our formula is T is equal to 0.09 into h divided by under root d. So according to this structure our value is 0.627. 0.627. This value is calculated from the plinth level. Okay, rest of the values are optional. Then if you want you can mention it, then click to OK. These values are sufficient. Now when you click OK, there is another tab open, that is self-fed. Self-fed, we are taking self-fed 1 means it is in STAAD Pro 1 means it is taking 100%. If I am giving self-fed factor 2 means it is 200%, means it's twice the weight of structure. So consider it 1 and click to add. See here your self-fed is added. Now mention your wall weight. In wall weight we are mentioning in terms of member weight command. In member weight command we are clicking loading type concentrated, and this is our uniform, and I have calculated that my floor height is 3 meter, and in this floor height 3 meter floor height we have to deduct the depth of the beam. So in our case depth of the beam is 450 mm. So it will be calculated like this. um, Floor height is 3 minus 0.45 into uh, the unit weight of your wall. So in our wall we are using bricks, so it is 19 point something, 19.6 as per code IS 875 part 1. So for calculation purpose we are taking 20, and thickness of wall we are considering thickness of wall is 8 inch, means zero point 0.2 meter. So it is like 0.2 meter into height of the wall into unit weight, so it comes something 10.2. So save this file, 10.2 kilonewton per meter. And if you want this 4-inch wall, according to 4-inch wall it will become 5.1, just half of it. And our parapet wall, for parapet wall you can take height is 1 meter, and unit weight is same 20 meter, and thickness of wall you can take point 0.2 or zero point 0.1 for 8-inch wall or 4-inch wall. Consider according to yourself. Say I have taken 2 kilonewton per meter and then click to add. So this will be the my wall load. Now next load is our slab load. Slab load comes under the command floor weight. So floor weight, we have mentioned floor weight that suppose if we consider the depth of slab is 150 mm, and unit weight of concrete RCC is 25 kilonewton per meter cube. So multiplied your thickness with your unit weight of concrete RCC, unit weight of RCC means it's something like this, 0.15 into 25 kilonewton per meter cube. Your answer will come 3.75. So add 1 kilonewton per meter square is your floor finish load. So your answer is 4.75 kilonewton per meter square. Now in this command you have to mention your range. Mention your range. Range means from where you are going to start this floor load. So to see this range, use note cursor. So go to left hand side, click to note cursor, and in this note cursor, if you want to give this load from here, so click to here, it will start from 2 meter, but I am going to assign this floor load from here. That is your Y range is 5 meter, means I am skipping ground load, because ground load itself transfer the load into the soil. So I take this range from 5 meter. 5 meter, and if you want to, you can separately provide the range, and there is one shortcut, provide direct range, click to top, that is 29 meter. So your range will be 5 meter, 29 meter. So your Y range will minimum start, this command start from 5 meter and maximum is 29 meter. Then click to add. Now what you have given, you have given the self weight, you have given the wall load, you have given the slab load. Now mention one more thing, live load. But in earthquake live load is not considered full. According to the page number 24, table number 8 in IS code 1893 part 1 2002, you have to see that table. If your live load is 3 or less than 3, consider 25% of it. If your live load is above 3%, take 50% of that load. So suppose we are considering 3 kilonewton per meter square is our live load. So in this earthquake we have to mention it's 25%. So 25% of 3 kilonewton per meter square is 0.75 and range is same then 8. So this is your slab load and live load. Now this question mark indicates that this load is not assigned. So we have to assign this load. To assign this load, what we are going to do, we have to select our beams. So I select all the members. So to assign this load, we have to select our members. This is our outer wall load. So go to select a menu bar, select beam parallel to X, then again go to select beam parallel to Z. See this in isometric view that all the member beams are selected. Wall load rest on beam. So the top portion is our for parapet load and this is our external wall load. So what we are going to do, we are going to remove that part. So first of all we select our desired members, then go to menu bar, select view, then click to view selected objects only, means unselected members are removed. So now go to front view and from beam cursor, this is our beam cursor, and click with the dragging option and select remaining all the members except top. See, then again go to menu bar, click view selected objects only. Now you can it will be more easy to select assign this load on this members, but in this case you have selected internal walls and outer walls both. So go to top view and in this top view, this is our top view, and in this top view select this portion and press Ctrl button in your keyboard and again click to this, then this and this. Don't forget to select Control button. So with the help of this we have select outer members, our load is selected, member is selected, assigned to selected beam, assign. Now select uh, interior walls. So click to 5.1 load, again go to top view. So with the help of drag command from corner to corner click to this, then select isometric view. You can easily see all the members are selected, then members are selected, loads are selected, click to assign to selected beam, assign. Then this is our 2 kilonewton per meter load and this is our parapet load. So in this diagram or in this frame we have to again recall our parapet. So recall our complete structure, select display whole structure, or in menu bar go to view, select whole structure. See, complete structure is displayed again, and in this load, this parapet load, we are again going to select front view and click top view, and in this top view we are going to work over this members only. So in menu bar select view selected objects only. So it will easy to identify your members. Again go to top view and in this top view click to this and press Control button in your keyboard and continuously select remaining outer members. This is your parapet wall load which is resting on this beam. Now load is selected, assigned to selected beam, assigned. Now our complete load is assigned in seismic definition. Now what we have to do, we have to assign this load in load case detail again. This we have mentioned in seismic definition, we have mentioned the parameters and magnitude only, but we have not mentioned the seismic direction yet. So in this load case, click to add, and number one, loading type, select loading type seismic and mention title earthquake. Earthquake EQ stands for earthquake, earthquake in X direction. Add again number two, loading type seismic, title earthquake in Z direction. Add. This will be the our load case, or you can call it folders. Now number three, loading type dead load, mention title is name. You can mention dead load, or you can completely spell it dead load. Dead load. Fourth one is loading type live load and title LL and add. Then close. Then click to earthquake in X direction, go to add, and in this dialog box, load item, see left hand side there is one option seismic load. In seismic load, STAAD asking about factor and direction. Click your direction, click your factor. Factor 1 means it will magnify your load into 1. If you provide 2, then it will twice the load. So don't use twice, use only 1. Then add and close. This is your 1893 is your earthquake code. Load X direction. Similarly, go to Z, and in seismic load, select direction, factor 1 and add and close. Now in dead load and live load, we have already given our dead load and live load. If you want, you can also copy paste this load from this load. You can copy paste this load and paste here, but it need little changes. So for beginners, we are again doing the same, and for advanced, you can easily do some little changes in editor and run the file. So for beginners, we are doing this dead load, and again same load. In dead load, first of all, assign add self-aid. This is our self-aid. Second is member load. In member load, in seismic definition, we have mentioned load plus 10.2. Here we have to mention 9.2 because dead load is our gravitational load and it will transfer from top to bottom. And in earthquake, we have not mentioned the direction because in earthquake we are mentioning direction here, X and X and Z direction. Our earthquake is acting in X and Z direction, not in Y direction. That is why we have not mentioned here minus sign, because we are not taking Y direction consideration. And in this case, we have taken minus self-aid minus 10.2, add it. Then we have also taken the another load minus 5.1 and minus 2, add and close. This self-aid is the self-aid of complete structure. So you can also use, as in assigning method, you can also use this command assign to view. And again similarly what we have done just 2-3 minutes earlier, we have to assign this 10.2 kilonewton per meter load again. Select your member, go to menu bar, select beam parallel to X, select beam parallel to Z. Again in menu bar, go to view selected objects only. So all the members are selected, but we are working on this member. This is our in this member beam we will assign our parapet load. So we want to again remove this. So again go to menu bar, select view selected objects only. Now it will be very easy to identify your member. Go to top view. This is our top view, and select this portion. See in isometric view, you have selected only this portion and complete member is selected from top to bottom. Here we are not getting problem of y direction. Your y direction is not here. Your columns are not here. So click control button in your keyboard and select your outer members. See, all the members are selected. We are doing right. Members are selected, loads is selected, assign to selected beam. This is your selected beam. Assign, then select load 5.1, then go to top view. You can drag here to here to select your remaining members, or there is wonderful command in STAAD Pro, that is go to select, and in select there is a command by inverse and click to inverse beam selection. This is inverse beam selection. In inverse beam selection, selected members are unselected, unselected are selected. When members are selected, load is selected, assigned to selected beam, beams is selected, assigned. Then assign parapet load. So to assign parapet load, we need complete structure, means whole structure. This command is available here in toolbar, and you can also get this command in menu bar. There is option tool, tools. Sorry, this command is available in view select whole structure. Here we get complete structure. So we need top portion. So we selected front view, and in this front view we click to top. Select isometric view to cross check you have selected correct member. Then in again go to menu bar, select view selected objects only. Then select top view plan, easy to select. These directions are very helpful for selecting correct members. So don't be afraid of selecting many times. This select isometric view to cross check that whether you have selected correct members or not. Top view, top front view, isometric view, these are very helpful for our members to select. And we have selected correct members. Load is selected, member is selected, assign to selected beam, assign. Then in this dead load, still slab load is remaining. So to assign slab load, we have not mentioned slab load continuously, because when we are assigning slab load, it will assign automatically, because we have provided range over here. So open your complete structure, click to display whole structure, and we need slab load in dead load. So click to dead load case, or you can call dead load folder. Click to add, and in this load items, see in left hand side there is option floor load. Floor load, mention this load in minor direction -4.75. We have already seen the range, that with the help of node cursor we have seen range. We have considered from here 5 meter to top is 29. We removed ground floor because we assume that ground load is directly transferred to soil. So in y direction, see here in load case detail, y direction comes in upward, range 0.5 to 29, and this is your slab load. Then go to live load and click to add. In this live load is 3 kilonewton per meter square, means this is load per area. Again using the same command, floor load, but here we are using this command in live load folder. We have assumed that our live load is 3 kilonewton per meter square. So we have considered here pressure is -3. Here we are taking complete live load, and in seismic definition we have taken 25% of this. So mention your range, minimum 5 to 09, and add and close. Now you need combinations to analyze this. So for this, go to load case detail, click to add, and for making combination one by one, use define combination command, and there is wonderful command in STAAD Pro. that in left hand side there is one command, auto load combination. Auto load combination, from where I get this command, I click to load case detail and click add, and in this load items, in load case detail, that in left bottom, auto load combination. Auto load combination means automatic load combination. Instead itself create its combination. You have to answer its questions. Select load combination code. Select your code, that is Indian code. Select load combination category, general or steel. We have selected general. Then click to generate. See, all combinations are created. And if you want to remove this 0.9 combination, so you can easily remove this combination by select this and discard load combination. So you have selected this and click to shift but option. You have discarded this 0.9 because this 0.9 combination is used in overturning structure. In our case, we are not considering this factor and it's not existing here. So in right hand side, selected load combinations are this, and we are going to add this combinations, 11 combinations, add, close. See, 11th combination we have generated, and 4 we already made. So this will be our complete combinations. And now go to material. We are still in general tab. Our next tab is material, and material is we have already provided material in property, so we can skip this tab. This command is used to create new material. Means if you want to make new fiber, any material, new material xyz, you can make from here. So in our case we don't need it. So move forward, click to print oblique analysis. Next to general, there is another option, analysis oblique print. This complete system is known as page control. Click to say analysis oblique print. Then a dialog box open, that its name is analysis oblique print command. Click in this print command. We need perform analysis. If you want to print anything in your output file, click to that, or if you want to skip it, you can skip it. Click to no print and click to add, close. See over here, this command comes in green check mark, means it is already assigned. So our 90% work is done. Now we have to analyze this structure. To analyze this structure, go to menu bar. This is our menu bar. Select analyze and click to run analysis. So this analysis depends upon your computer processor. So maybe it will take time. It will hardly take 5 to 10 seconds. In my case, it is it has taken 10 seconds. Zero error means we cannot bear any error. The error means in a structure there is, from error point of views, it is okay. One warning and one note. So we are reading this, what is the warning and what is the note. Here error, we can't bear error, we can't come forward with any type of error. And then warning, it means may or may not be ignorable, and the note is completely ignorable. So to view this note warning error, go to view output file and done. Note, this command says about floor one way wait, means in this command is note is explaining that your floor load command, what you have mentioned, is directly mention that command in multiple times. Means go to room wise, floor wise. In one floor there is 9 rooms, so you have to mention this command in 9 rooms. And if you have 10 story, so then you have to mention this 9 into 10 times, it will be 90 times. And you have considered this floor load in dead load, in live load, means it will be, suppose it will comes in 180 times, so it will be very hard. So this warning is completely ignorable. Not about floor load one way and wait, break up this command to multiple commands, so we neglect it, ignore it. Then come to warning. This warning says if this UBC IBC analysis has tension compression, means this says if this is UBC IBC means universal building code or international building code. If this universal building code, so in our case this is Indian code, so again we will ignore this warning, and this is our uh, base shear. This is time period what we have considered. This is V is equal to H into W. This is H and this is W. The rate of structure H is equal to horizontal seismic coefficient, and your state file is completely analyzed. If you want to see any structure, any result, go to post processing. Click to post processing and option. See here you can easily see the results, all the results in node displacement reaction. This is here it's a reaction, but it is very hodge. So you can see reaction according to the node wise from here. This is support reaction type. And from next step in this page control beam, in this beam you can see forces, stresses and graphs. And third tab is animation. In this animation means you can see the behavior of the structure. So when I click the animation, one dialog box open named diagrams. Here diagram type is no animation. Change it to deflection and press apply. See here, you are not able to see the animation of that deflected shape. So what we are going to do, we are going to change its scale. So means I am going to amplify the scale. So go to scale, and in third bottom see deflect displacement, and displacement is 1000 mm per meter. 1000 mm means meter per meter, so change it to 100 mm per meter, and again click to apply. See, is there any change? It's changing little bit. Make it 10 mm per meter, then again see here, this is the your deflected shape, and this deflected shape is of live load case 4. You can see this here in active load. This is deflected shape of active live load. See here, this is the deflected shape of earthquake in x direction. Your structure facing earthquake in x direction, load and behaving like this. Similarly, you can change it in z direction. This is your dead load, live load, and this will be your combination. In this combination, STAAD automatically creates minus x direction and minus z direction. So this is a small video for analyzing earthquake. So if you want to see the diagrams also, or loading how it acts, you can also see from here loads. See here how your earthquake in x direction and z direction behaves. See here, when in your structure earthquake in x direction is acting, your structure behave like this. So this is your displacement, deflected shape, and with the help of animation we have already seen the animation view. So that's all for today's. We will continue in next session. Okay, thank you, and keep watching Gravity CADD's video. Thank you.